So it's just a little after 4 now. It's been cooling for 5 minutes. I put the ethanol on ice to cool so that we can use that for washing our solid, assuming solid forms. This has pretty much reached room temperature. It's a little warm still, but not too bad. So what I'm going to do is just scratch the walls a little bit, see if I can induce crystallization. I've also got a little bit of a seed crystal on there that could help that. And you'll see that as soon as I did that, crystals started forming. So I got a good amount of solid coming out at this point, and it looks like it'll be filterable this time. Kind of an orangey solid. So that's a good sign. There's so much solid now that's crystallizing. Obviously I had a supersaturated solution. There's not that much liquid left, which means that's going to be a little hard to filter, but we can add some cold ethanol to help with the filtration. So we do have a solid out. So even though we couldn't filter the crude and do that 2 milliliter water wash, looks like we're going to get a decent yield of material, hopefully fairly pure. Can always recrystallize it again if it's not pure enough the first time. So I want to let that really reach room temperature, and then I'm going to put that on ice as well, but I may add another milliliter of ethanol before I ice it, just to make it a little bit more of a slurry rather than a solid. That's what you hope for in a crystallization where you scratch the walls. You hope it'll suddenly do that. Keep that for now. Pretty damn soluble in this stuff, since we only needed a very small amount to crystallize it. So I definitely don't want to add too much in getting my filtration to work and risk losing compound. But I will need to add some in order to get it filterable. So I'll just reach in there and stir it. You know, maybe it'll be filterable without adding any more. Now that I've broken it up, it does look like it'll filter. I don't want to ice it prematurely because cooling it too quickly definitely increases the tendency to form oil. But I would like to ice that because it's so soluble that I think I'll lose material if I don't use ice cold solvent. I'm not letting go of this because it will dump and fill with water if I don't keep an eye on it. Let's dry that off. Just going to wet that filter paper down again so it's freshly wet. And then I'm going to try to dump this at once, get as much of the solid out of there as I can before I wash it with the cold solvent. Looks like the product is pretty much white once it's free of the impurities. So now I'm going to rinse that, just say 1/2 milliliter of the cold ethanol. Just try to get that last little bit down off the walls. Pour that in there. A little bit of solid left still. Maybe another 1/2 mil. Being cautious not to use too much because I'll lose compound if I do. And pull those boiling stones away with tweezers once the whole thing is isolated. So there's a little solid I'm losing, but I'm going to call it good. And what I want to do is just rinse with just a little bit of ethanol. Try to get that residual pink color out of there, because that pink color is an impurity. This compound is quite white. Maybe a little bit more pink down there. Trade-off here between getting rid of that last little bit of impurity and losing a little compound. And I'm going to call that the law of diminishing returns. Probably measured maybe 2 milliliters total, about 1/2 milliliter each times 2, and then about another milliliter of washing those. Got an orange filtrate. Impurities are in there, and our solid is pretty white. And you can see it's kind of a fine, needly solid. So I'm going to allow some air to flow through that. And we're going to be doing our usual, I don't need the ethanol anymore. Should be done with the ice bath. So we're going to do our usual trick of measuring that into a tared 10 milliliter beaker with a label on it, preferably a clean 10 milliliter beaker. And this for me will be DCL-10-57B, recrystallized solid. And we're going to weigh this beaker. You will, of course, not be able to calculate a percent yield or even an accurate theoretical yield until you've identified your compound, and then you'll have to redo your pre-lab table unless you happen to have gotten lucky and been given the ones that you did your pre-lab based on. So it looks like we're at 8.305 grams for the beaker with its label. It's empty. And I'm out of 50 milliliter beakers in my hood, so I'm going to steal a 50 milliliter beaker from this hood to nest that in so that it can go in the desiccator. It'll have to stay overnight in the desiccator because there's water. Just grab a suitable spatula for scraping that out. I think in this case, I'm going to scrape that out with one of these smallest micro spatulas instead of the ones I usually use. I don't know why there are two things of pH paper in here. Let's consolidate those so we just have one. This one aside can be refilled. So later. So I'm done with the 10% hydrochloric acid. Put that back where it came from. I don't need these anymore since it did work the first time. Break that vacuum gently. You see one boiling stone right on top, so I'm going to remove that immediately. Another boiling stone in there somewhere. And we're just going to transfer this solid to the beaker. Here's that other boiling stone. No trouble getting it away from the solid. If I can leave the filter paper behind, that would be a bonus. Looks like it wants to come out though. Just a little bit of solid on it. Filter paper is just as good as the spatula for getting that solid out of there. Let's weigh that now, and then we'll get a more accurate mass tomorrow after it's had a chance to dry. Looks like 8.534 grams with the solid, 8.534 grams. We'll add that to our large number of solids drying in the desiccator. So it's time to get a melting point and some NMR data once the NMR is working again, so we can identify what that is. So that's really all there is to the aldol condensation. It's a pretty simple reaction.